First of all, I'm not too sure why these fellows, friendly Malaysians, wanted to mention about Chinese police right before I start. But anyway. So, this is me, all right? I work in this company called JD.com. By looking at the name, most probably you can guess it's a Chinese-based company. And yes, I stuck in China since end of January until now. This is the longest moment in my entire life that I miss nasi lemak for 10, 11 months, and it's going to be bad. And I'm not too sure when can I go back for curry mee, laksa, nasi lemak, and whatever food that... Oh, rendang. I miss rendang too. But yeah, I'm in China right now. I'm a Malaysian, and they want me to specifically mention I'm from Penang, so that's pretty much me. Most of the time, during my office hour, during my non-office hour, I'm doing a Qiling framework. In all the presentations and all the different people that we meet during this entire development and sharing this project, just like how we shared, just like how people shared all the good things in their life, there is some feedback and comment, especially from Chinese. They say Qiling's proper spelling is Qiling and Qilin, and why I spell it Qiling. The reason why I screwed up when I did my spelling. So that's pretty much it. Some of them pronounce as Qiling, whatever. It doesn't matter as long as this is a framework. I also did some batch, for Hack in the Box and cover conferences, all right? And the rest is not important because you're going to see that later in the slides. Okay, so I will take this as an example, okay? I will take this as an example. The reason why it's, and this example is a little bit over-exaggerated. Just imagine any IoT hackers. Okay, of course, Qiling it's not limited to IoT, but just imagine any IoT hackers or firmware hackers or any reverse engineers. They wanted to reverse a car. So the rule of thumb for IoT hacking, it's you need to have the device before you can reverse the firmware. But the entire idea over here, it's just imagine if you need to reverse a car, you need to have the proper car, and then there are how many models of car you want to have and how many brand of cars you want to have. All right. In Malaysia, maybe we can do it. We have a big garage that most probably you can put 2 or 3 cars, and that's only 2 or 3 cars. Okay, and you are expecting yourself. You don't want to break the car and during the entire reverse engineering process. So the entire idea of Qiling Framework, it's without owning the car. Again and again, I say that this is just an example. So without owning the car, can you actually reverse all these IoT devices? Okay, so let's say to fake the GPS, to fake the Wi-Fi, to fake the Bluetooth, to fake the audio devices, to emulate the screens along the way when you do your entire reverse engineering. So the entire design and idea over here, it's you wanted to have a framework that can help you to emulate all the connections. Okay, again, Wi-Fi, Bluetooth, or whatsoever, and you will be able to have the complete emulation for your to have the complete emulations for your reverse engineering purposes. Okay, so that's the entire idea when we started to design a Qiling framework. Oh, can I say hi to Ken Seong? So when we reach this stage, the only thing that that people ask is there are virtual machines, okay, at least at the very bare minimum, at the very minimum stage, you do have a QEMU, but QEMU will not be able to bring you to a lot of places. Okay, so let's say you need to emulate MBR. Yes, Bosch will be able to help you to emulate quite a fair bit of MBR, but how are you able to do an instrumentation on a MBR? You cannot do it. You don't have the proper tools and the proper you don't have any proper things to do your instrumentation on your MBR smart contract. There is quite a fair bit of emulator out there. People can emulate, people can run. But when it comes to instrumentation, when it comes to fuzzing, how can you fuzz a smart contract? You need to build a bit part and parcel of everywhere of the tools, and to match to make some other non smart contract design to tools to in order to make this thing works. Okay. UEFI, I don't think there's any proper UEFI emulator out there, all right, except us able to emulate UEFI. Let's look at things like Qualcomm EDL, a very low level system inside a Qualcomm chips that able to help you to unbrick your phone that it's not patchable, and apparently there's quite a fair bit of bug. So in order to emulate and to instrument and to run these things, okay, there is no proper emulator for you to do it. Okay, so virtual machine will not be able to help you to emulate or to instrument all these kind of tools. Of course, when it comes to any OS debug, so let's say your kernel drivers, your binary, you want to do there is a debugger detected, or there's anti-debug techniques. How are you going to solve it? I mean, you can solve it easily, but what if you do have a system don't have any anti-debug mechanism? That will help you to solve a lot of shit. Okay. The one of the last thing that I mentioned, it's more from the previous slides. It's hardware emulation. So let's say you want to emulate some GPIO connections with some proper hardware to fit into your IoT system. So that is most probably the most important thing for a IoT reverse engineer, and to emulate all that kind of hardware. That is what we can do. So this is the entire overview of Qiling Framework. Okay, and this is what you're gonna what you're gonna have. The very base design of the framework. It's the framework itself. Of course, it comes with CPU emulations, loader, OS, debugger, all the way to extension, and then in the middle, and somewhere in between the external hardware emulation and instrumentation, you do have you will be emulate all kind of hardware. Okay, depends on how you want the system to do it. Okay, how you want the framework to run it, and what kind of data you want to fit into the framework. And then you do have the CPU architecture. All right, that is what we support so far. And then when it comes to the loader and OS, it's two different things, but for a lot of people, it's going to be the same category anyway. So you have your Linux loader, your BSD, Mac OS, Windows, DOS, UEFI, Qualcomm EDL, master boot record. We are still finding ways to run iOS, and then we can run quite a fair bit of Mac OS binary, but still not really there yet. Okay, and on the debugger part, okay, the debugger part, we do integrate IDA Pro, be able to run with IDA Pro, and then we do have our small little QDB toys that developed by one of our contributor that will allow you to do reverse debugging. So you can step forward, you can step backward, and then all sorts of stuff. Okay, so and then we are still planning on a G Hydra, and of course we support GNU debugger. And the extension part, we really have a few things running. We have a hip sanitizer, we have our coverage, guided coverage, and we do have a report generator that able to generate all the JSON files, the information that required by by the malware analysis gang. So these are pretty much the overview of Qiling Framework. Okay, so the features and functionality is pretty much here, like or what I mentioned just now. The only thing that I would like to add, it's we support cross-platform and cross-architecture, not only on the emulation part, but simply on the also on the execution part. So you can run a Qiling Framework on Windows, you can run it on Linux, you can run it on Mac, and you can also emulate these three systems. All right, and also on different architecture. All the executions, it's on sandbox, and it's in an isolated environment, so you don't have to worry about they are messing with your actual file and system during the entire emulation, especially when you are emulating malware, APT, and so on. Okay, so of course, the most important thing over here is the instrumentation. So what kind of instrumentation we able to provide into all these CPU architectures and OS? Of course, you can debug. We can even debug step forward up to the stage of UEFI or MBR or Qualcomm EDL or up until that level. Okay, and then we do have this small little thing called OS profiling support. The entire idea of OS profiling support is you can do your settings. You can set up your OS before you run the entire system. So just imagine you wanted to run a firmware that's suspect from Russia. All right, and then you want to emulate the entire system that looks like a Russian system, a Russian keyboard, a Russian Windows. You can do it, and then you can have another copy of emulation that runs on let's say on the Chinese system. So you can set your Chinese language, your Chinese keyboard, or whatever. So it's everything on one configuration file that you can do all kind of OS profiling based on the reverse engineering conditions that you want to go into. So this is the entire design that allowed you to change the settings and just put and just runs your system. So and then recently we see quite a bit, all right, not to say a lot, but there are 2 or 3 similar project that pops up either at the same time that we release or slightly earlier. We release Qiling Framework or until the current stage. All right. So of course, when it comes to reverse engineering for IoT devices, especially a cross-platform Linux-based system, the most common tools that the reverse engineer previously used is QEMU user mode. Okay. Few problems with this and a few issues with this. Number one is all these tools are QEMU user mode are designed as a tools. It's not anything for reverse engineer. It's able to emulate, to run, and they are not able to do anything else. Okay, and one of the dead end for reverse engineer, it's rely on syscall forwarding. So if you need to analyze a Mac OS file, you want to if you want to emulate a ELF binary, you will not be able to do it on a Mac or FreeBSD or even Windows. All right, you need to be in the same host to emulate the same the same target that you're gonna look at. All right, and then a couple of years back, one of the guys they released a thing called UserCon. All right, good and bad things. Okay, it's a framework. It's able to do some level of instrumentation, but the only thing is they rely on Go and Lua language. It's not a hacker-friendly language. Okay, I know a lot of people are gonna bash me for this, but I'm still gonna say it. It's not really a hackers-friendly language. Okay, and we do have things like Wine. Okay, we do have things like Wine. they're able to run. The only limitations over here, it's not only limitations. The limitation, it's they doesn't support multi-arch. They doesn't have a lot of OS support. All right. It's not a sandbox design. They only support Windows. It's not sandbox design. And then you don't have instrumentation. All right. So the new player on this ground, okay, after we release is number one, of course, is Beanie from Carbon Black. They only support Windows, and they only support 32-bit and 64-bit. Again, it's running on Golang. They release around last year's if I'm not mistaken, last year's DevCon, but it's not really active recently. At least for the past 6 months, they are not active at all. And then Zelos and FireEye. Zelos is from one of the company from the States. Okay, of course, FireEye is from that part of the world too. Both of them are framework. Okay, Zelos only supports Windows. Zelos only supports Linux. SpeaksEasy only supports Windows. And SpeaksEasy, yes, they can do PE files and Windows driver. All right, Zelos, they only can do ELF file, but not Linux drivers. So not Linux kernel module. So you do have all these projects running around, but they are not complete in the sense of they are not cover a lot of platform. They are not cover a lot of architecture. They cannot cover things like from files to kernel level, which we can do it. And then they don't have a very complete, a lot of them don't have a complete instrumentation, which we are our strong forte. So when it comes to explaining Qiling, you know, I'm working in this part of the world, and then sometimes I do have to explain what is Qiling and framework, and a lot of people don't get the idea of framework. So when we started to share our session, a lot of people will started to ask, you know, what can your tools do? It's not about what can our tools achieve or what can our tools do. It's all about what can you do with what kind of tools you can come out with our framework. So there is a couple of projects started to use Qiling. One of them is from tools from Sentinel-1. You know, we have things from this FireEye inside our plugins, and then we have this very good reverse engineer that does the VAC emulator. So they started to build UEFI fuzzer malware decoder. You can even build a malware sandbox, and then you have things like iOS emulator, macOS emulator. These are the ideas that you know, you can build on top of Qiling framework. Of course, not limited to all these kind of all these tools that I mentioned. All right, you can build more and more stuff using Qiling framework. And why I split into the CPU architectures, loader, OS, debugger, and all these things, because we do have instrumentations connections, or we call it the Qiling's API that you can connect to, and then you can start to do all the things within the framework itself. So the topic of today, we're going to talk about instrumentation. So when it comes to instrumentation, all right, when it comes to instrumentation or the API that able to help you to instrument your reverse engineering activity, the thing over here, it's you have, so example, you have a binary, and then the binary will execute from A to B, and then to C to D to E to F. All right, so 1, 2, 3, 4, 5, 6 steps, and then that's the end of the binary. Okay, so instrumentation simply means you wanted to start at B, okay, and then you're gonna change the you're gonna update the syscall, or you're gonna mess around the syscall, then you're gonna mess around with the functions call, and then you want to skip C, you want to continue D, and then you're gonna change the CPU register, then you're gonna end in E. Okay, that's the entire idea of our version of instrumentation. So reverse engineers always knows that you want to skip certain part of the binary during analysis. The entire reason it's there might be some part that you don't need to analyze, and that part is a big chunk of code that might take up a lot of your time. So if you can able to run it this way, then that will bring you to another result whereby you can actually run this thing. You can actually run this binary over and over again in a fuzzing process, like what Ye and Nafis shared yesterday. So you can run over and over again in the entire fuzzing process for you to fuzz only this part of the file. So instead of wasting 10 seconds, all right, for you to run through from A, B, C, D, E, F, and now you might be able to run B, C, B, D, and E with all your syscall authoring, your function authoring, your CPU registration authoring. Okay, then you might finish in 2 seconds. So this is how you can able to save time for during your entire fuzzing and discover more bugs efficiently without running or analyzing the code that you don't need to. So that is everything about instrumentation. So this is the API. So what do we have inside our Qiling's API? It's we split it into the CPU level, operating system level, file system level, virtual machine level, and the debugger level. So after we load in the file, it's either ELF file, the MBR file, or the DOS.com file. Then that is where all these things started to kick in, and then that is where you can do your instrumentation. So there are some API that perform the instrumentation is a little bit cross-border. So it's either in file system or it's either in operating system, or they're in both places. But please bear with me. There are certain parts the API is the definition of the categorization of the API is a little bit blurry. So they might be here and there. So please don't mind. So for CPU register, CPU register alteration is very simple. You can either change or you can either read the register. You can write into the register by using the API. So this is the example. You look at the highlighted part, that will be your RAX. Okay, so that will be your RAX, and then this is how you can read your RAX. This is how we can you can update or replace the RAX. So this is what you have. Down there will be a little bit more API that we will be able to share later. So that will be replacing syscall during enter into the syscall, updating syscall when you exit the syscall. So you can do all that. And then there is a thing called set API. That is your library replace function. So you want to replace a certain function inside your libc. Yes, it's totally doable. So you can read map, you can map, you can do all sorts of things. Okay. So in the operating system level, there are certain things that you might be interested for a lot of people. You can read the memory, you can write into memory, you can even do a pattern search inside the memory. So when you are emulating a ELF file, you want to search for certain strings. So let's say a simple CTF solver. So once you are running it, and then you just want to search for certain strings that starts with what kind of character and end with what character. Yes, it's all doable over here. So for your pop push for your stack related operations, okay. Like what I mentioned just now, syscall or library replacement, everything can be done from here, regardless of you're emulating a Windows or Linux. So there's an example over here. So this is a very good example on how you can replace a Windows syscall. You can replace a Linux syscall right into your own implementation of syscall right. So we also have a file systems API. File system level API will be things like so let's say your stdio replacement, so you can hijack stdin, std out, std error. Okay. We even have things like patch, so you can patch the file during executions, and then you can test out the executions if you want it. Okay, along the way, then only you decide where to patch the file uh physically. Okay, so the patching inside a Qiling framework is you look for address, and then you replace the execution code before you run it. So this is how you can patch the you can actually patch the entire binary without touching the actual file. So we also have this thing called a file system mapper. So you can always map a file. You can always map a file into your whole system. So if you want to during the entire emulation, you want, and then you discover your binary is actually taking a urandom, you can always map your file into the whole system's urandom. That is where you can get your proper randomized value. So if you are not interested in doing this thing, you know that your binary is running on is doing a urandom, and then you do expect, okay, for some reason you only want your urandom to return hex 01 value, and then you know that regardless of what kind of for whatever reason you only want your urandom to return hex value 01, then you can always force your urandom to reply fixed value reading for your urandom to return back that kind of value. So you can do that. You can force that kind of a value. The virtual machine, it's very simple. So the virtual machine state is just imagine you're running on a VMware and you want to do a safe state. So during the emulation of that binary, you can choose to save the entire snapshot. So that includes the CPU register, the memory layout, the FD. So you can save the memory regions, you can save the register region, you can restore the register region. So that will be able to allow you to do your fuzzing. So we do have a small example over here. So you can save, then you can restore back, and then you can start from certain parts that you want. So we don't have the start of certain parts that from the binary. So just imagine you can always save, you can always analyze a part of the file, and then you know that you want to start from certain address, and then from certain address the next execution, the next execution, or whichever execution you always wanted to start on that part, and you want to patch certain memory or certain area of the binary, you always can use these functions to do it. That will save a lot of our code executions when it comes to things like, you know, how you want to mess around with the entire systems, and your binary, where to start, where to stop, and how are you going to how are you going to able to patch it. Okay, the last part will be the debugger. So the debugger part, it's rather simple. Whoops. The debugger part will be rather simple. So you can switch to a different debugger. You can switch to a GDB. You can switch to our own small little QDB that are developed by the community. So so that's pretty much about the debugger. So you have your file pass into the framework, and then the framework will load and set up according to the API, the instrumentation that you put in. Okay, then you will be able to run to emulate the file, and then you have your engine, and then the rest will be the results on how you're going to analyze the system based on the result and the output. So I think this slide will be distributed by NanoSec, so you don't have to copy or screenshot these things. Okay, so these are the certain things that you can do. Okay, you can analyze malware without having a full execution of Windows, you can just analyze by using a Qiling Framework. And then, yes, we support PE file and we support a .sys, a contribution from Debugger teams. Okay, then we have all these anti-debug system. Basically, we don't have any anti-debug system. So any anti-debug code that comes into Qiling Framework, they will not work. So it's a good thing for everyone. Okay. And then we have this cross-platform support. Of course, you can run in Windows. You can run your Windows code in Linux or whatever. You also can build a fuzzer that is inside our example. So inside our GitHub repo, then there is an example. So you can put in your code. You can start to test out the different fuzzer. I will show you a video on MBA analysis later. So this is from one of our team member. He wrote the MBA analysis and then he recorded the video. So you guys can take a look later. IDA plugin also from the other member from our team. So the entire design over here, it's we wanted to use IDA, the strong IDA function that you can do reverse engineering, you can do all kind of stuff. And then we wanted IDA to have the instrumentation features in IDA Pro. So in order to make this work, we need to write a IDA plugin, and then to make use of IDA reverse engineering features, okay, to bridge over to a Qiling Framework. And then that is where IDA will have their instrumentations, the power of instrumentation. Inside IDA, we also can make use of the IDA to do the execution path drawing. So in execution of one binary file, you will know that which part of the file is actually being executed and which part it's not. So we will be able to draw out the entire execution path. So it's much more easier for you to trace when it comes to reverse engineering. So I'm going to show you some demo over here. So okay. So this is the code for to analyze this thing called Dodgy 8086. So it's basically a flare-on 5 challenge for MBR. So what we did is we load the entire MBR into Qiling. Okay, and then it goes into a first stage, second stage, and third stage. Inside first to run it, and then we're gonna hook in a certain part where to start and where to stop. And then this is how it looks like during executions. So there is a specific requirement for the date. So you need to make sure your system date is February something 1990. So what we're gonna do here is we're going to change the required time. So from here, you can see we can set the API, the required date into a specific date that we set. So you don't have to change your BIOS time or whatever in order to run this kind of analysis. We are the system, so we can control the date time. So once we change the date time, then we will be able to execute. So you can see the second stage is the one that we started to do some sort of key guessing. Okay, we do have enough time. So we're going to calculate and search for the possible keys. Okay, and then the third stage will be to print out the keys and then to test out the keys. So it's 3 different stages. One is to do the times, to change the timing. The second part is to generate the keys. The third part is to test the keys. Okay, so this will be the entire demo all about, and this is how the code looks like. So you can see we use a different Qiling's API over here. We use ql.restore to store the stage, memory write to change the memory segment. Okay, and then to run from certain part and end in certain part. All right. So that is where the code from 801B and then to 803D that we highlighted just now. So to restore the code, to run the code on certain steps, and this is how we execute the code. Then this part, we will actually change the time, okay, and then we discover the possible key, bunch of possible key. And then after we decide, after we able to search for the bunch of possible keys, and then we will test one by one until we get the right key. Okay, so this is one of the right key, another right key, another right key. So this is a very classic, nice CTF. The reason why I said so is you have a few possible keys, so you might have a few possible answer for your entire solutions, but they only display one email address. So that is the email. So for whoever familiar with flare-on challenges, you will know that you need to come up with you need to send an email, the specific email address that will be the answer for your entire CTF solutions. Okay, that is flare-on, one of the level for flare-on 5, and okay, what do I have? So this is another binary also on flare-on 5. Or didn't mess up the flare-on series on these things. So this is how we can use IDA together with Qiling Framework. So we can load our plugin into IDA. Okay, so this is still we did the recording sessions earlier on, so we're still on 1.2 dev. Okay, so so you can see there's a lot of a lot of code that you need to analyze inside the entire system, and then that's where they of course that's where they validate and to check the input. So these are part of the code that pretty much you're unsure on how and what will happen to these things, and then you can see it refers to magic table for the encryption, and then you have your encryption and decryption function over here, and there's certain parts that you cannot easily analyze. All right, so we load in that's where we can load in our tools, load in our framework into a Qiling Framework. We can load in a Qiling Framework into IDA Pro. Then that is where you can start to have to analyze junk code like this, all right, in a proper way. So we're going to check the functions over here, which again another bunch of things that you don't want to see. Then there's some breakpoint being set. So like what you can see from this binary, a very typical CTF challenge, a lot of code which is being messed up, and then these are some of the things that if I'm not mistaken, we rename during the recording process. So once looking at the code, and then we need to load in our custom scripts, okay, and then the binary file and the root fs. So during the execution, it will execute two things. Okay, of course, the binary file together with the scripts that we wrote just now. So that is where you can view the register. Then you can view the memory. You can view the stack. You can view you can have the complete memory view. So you can see this stack once they stop there. So the RCX value is identical. So then we need to check out the where's the RCX value. So that's the RCX value inside the text segment. So the code is going to be messy for now. Then we can have the more readable code over here. Then you can even F5 it to look at it properly. Then you can start to do your code execution. Continue running it. So this is the custom script that we're going to show it to you later. And I think it's in our repos example, so you can take a look at our repos. So you can simply restart the engine. You can restart the scripts. So this is the path executions drawing. When does it start? Where does it stop? And then how does it run? So the green color, the one in green is it's all the code that are being executed. So instead of junk F5 code that you have seen just now, so this is the translation of the code that the translation of the code into a more readable manner for reverse engineer. So everything is from the combination of the strong reverse engineering binary reversing power of IDA, and then to combine with the instrumentation for you to get this kind of result. So that is the demo. The only thing over here, it's where is my, so the only thing over here, it's there are quite a fair bit of things that we need to complete. Number one, it's can we need to work on Unicorn version 2, the entire backend of our CPU emulation. So the relationship is Unicorn will be handling the CPU emulation. We will be handling the OS level emulation. So can we have the latest CPU? That is what we wanted to achieve in these few months. Hopefully this year or not early next year. Okay. Android Java bytecode instrumentation. That's something that we are looking at right now. Of course, to emulate iOS, not only iOS, okay, but also Mac OS ARM64 version. Our Windows API is farly not enough right now, so we need to have more Windows Cisco or Windows API. So we are still looking at Wine or some other options to make our Windows greater. All right. MCU emulation, yes, that's part of it. And then smart contract emulation, we already have we are making a very good progress on smart contract emulations, and hopefully we will be able to release that in a couple of weeks time. Okay. Join us and please make a pull request. We don't have any we don't see any code contributors from Malaysia yet, so if you guys are interested, please contribute to the project. So all the informations on the it's right over here, the website, the GitHub repo, documentations, our Telegram channel, okay, Twitter, and please go to our repo and give us a star, or else we're gonna be very sad, every time we give talk and then there's no star. All right, and questions? I think you guys will be able to ask from YouTube, no? Oh yeah, we do have oh, no. Somebody told me about Marcus. Yes, Marcus is he's not a contributor, come on. He's a core dev, so it doesn't he doesn't count. It's not the text is from my Telegram, not from YouTube. So any more questions? Bloody Queen. Can you update your QEMU and stop messaging me? You shit. I will ask Chinese government to send an army to Singapore to catch you.
So there's one question. What is the optimal requirements to run Qiling?
What optimal? Are you talking about CPU requirement or RAM requirement?
I guess so.
Well, you can run it on Raspberry Pi if you want. And you can use Raspberry Pi to install Linux and emulate Windows using Qiling. Perfect.
There are questions in the Zoom chat, if you can check. This is an off-topic question. They said, no freebies like stickers or t-shirts this round. I think this is a note to last year's presentation by you.
Well, I mean, how the fuck I can give it to you guys? That is the questions. I can give, you know, it's like what? Like that? or like that. Hey, take a snapshot. That's yours. Who asked that question? I gotta cook that fella, man. How am I supposed to look at the chat? Where is the chat? Oh, alright, there you are. Okay. There's somebody asking, is this session being recorded? No? Yes? I don't know. Well, I think YouTube will have some replay for sure. Any more questions?
No, there's no more questions.
Okay. So anybody from Malaysia care to send me some nasi lemak? Okay, then we are good. Thank you very much.
Sniff it will send.
Sniff it was a nasi lemak. Okay, sniff it. I'm gonna wait for you, man. Sniff it. Like DHL. 2 hari lambat.
Post lagi lambat.
I actually Malaysian or not? Oi. Don't like that lah.